I'm Alexis Robinson. This is Lab 2 Projectile Motion. The table of contents includes goals, intro, tracker analysis, glow script analysis with and without air resistance, results, compare, and discuss. The goals for this lab are to observe and measure position of the paper ball using tracker, and then compare that with a computational model both with and without air resistance. And the assumptions that I made in this lab were that we were only tracking motion in the y direction, and at one point we are assuming no air resistance. The important topics for this lab include Newton's second law, which is the velocity update and position update formulas, and then also F net equals ma. And then also acceleration due to gravity, which is this formula, which gives us 9.8. And then also air resistance, which is opposite direction of the moving object, which is this formula. The system is the paper ball, the surroundings were everything else, and this kind of shows the relationship between drag and gravity. The tracker analysis gave us these results. This is my data table with time and then position x and y, even though we are ignoring the x. And then here is my graph for the y position. The initial conditions whenever we assume no air resistance were these. And then b equals 0, which means no drag, and it gave us these results on this graph. And then whenever we did assume air resistance, we used these initial conditions, and this is what I made the drag, which gave these results on this graph. So to compare, so the blue is in tracker, the tracker is in blue, the glow script with air resistance is in orange, and then the glow script without air resistance is in gray. Obviously, the computational model with air resistance and the tracker are most closely related, considering the air resistance is something that happens in real life, so they most closely mock each other, versus the glow script with no air resistance is just the straight line down. It doesn't really take into account things that would happen in real life. Some sources of error in this lab were incorrect mass because I didn't weigh the object. I kind of had to assume what the weight would be. And then also incorrect air resistance because I kind of had to guess what that would be. Terminal velocity is achieved when air resistance is equal and opposite the weight of the object. So the second model that includes air resistance would predict the terminal velocity since it includes air resistance. And it would take longer for the ball to reach the ground if it was thrown straight up, as it must travel up, stop, and then fall down. So the formulas for finding the time for throwing it vertical and throwing it horizontal are listed here, and obviously it would take longer to throw it vertically. So yeah, thank you.